The topic is understanding Docker Swarm versus Kubernetes, Docker container versus Kubernetes pod, what is a namespace, the role of kube proxy, NodePort versus load balancer. Docker Swarm versus Kubernetes. While both are container orchestrators, they differ significantly in scale and capability. Docker Swarm. It is built into the Docker engine. It is focused on simplicity. It is easy to set up and great for smaller projects where we just need to run containers across a few machines without complex networking or auto scaling. Whereas Kubernetes or KATS is built for complexity and scale. It offers advanced features like auto-scaling, self-healing, restarting failed containers, and intricate networking. It is the industry standard for production-grade enterprise environments. So we know that these both are container orchestrators, meaning Docker itself or containerization is just containerization concept, whereas we need orchestration of it that is better than containerization. So these both are orchestrators. Simply, these both are container orchestrators. Docker Swarm is for smaller projects or teams that are really small, not big organizations. They can implement Docker Swarm as it is simple and easy to set up, and we would just need to run few containers across the machines without complex networking or auto scaling. That is a concept in Kubernetes. Whereas in larger organization where there exists scalability and enterprise production grade environments, this is the industry standard because it is built for complexity and scale. Kubernetes offers features like auto scaling, self-healing, that is restarting the failed containers, and integrate networking. So this is a standard. And Docker Swarm is used for smaller projects or small teams, whereas for larger organizations that build complex and applications that would be having a lot of traffic and a lot of users handling it. So for bigger applications and bigger teams, there is a concept of Kubernetes. However, today's world, we always prefer Kubernetes as a skill, so it is just for knowing and understanding, whereas Docker Swarm is still used by some organizations, whereas Kubernetes is a standard right now. Even if it is a small organization, they would still need you to learn Kubernetes as a concept and for practical as well. So its feature, that is setup, Docker Swarm is fast and easy, whereas Kubernetes is complex and intensive. For scalability or scaling, Docker Swarm is manual in scaling, whereas Kubernetes is auto-scaling based on traffic. For flexibility, Docker Swarm is limited to Docker ecosystem, whereas Kubernetes has highly customizable supports various runtimes. That was about Docker Swarm versus Kubernetes. Now Docker container versus Kubernetes pod. The fundamental difference is how they are managed and isolated, meaning Docker container, this is the smallest unit in the Docker world. It is a single isolated process running our code and its dependencies, whereas Kubernetes pod is the smallest unit in Kubernetes. A Kubernetes pod is a wrapper that can hold one or more containers, meaning containers inside the same pod share the same network IP address and storage volumes. We can think of pod as a house and containers as room within that house. So the simple differentiation between these is that Docker is the smallest unit in Docker world and Kubernetes pod is the smallest unit in Kubernetes. Docker, it is a single process that is isolated, running the code and its dependencies, whereas Kubernetes pod is a wrapper that holds these containers that can be one or more. If there are more than one containers, that is two, they will share the same network IP and storage volumes inside a pod, and we can think of pod as a house and containers as room within that house. Also, a difference is Docker container is independent of YAML, whereas in pod we specify pod specification, which is exactly similar to the Docker file. So we write that in the YAML file, that would be pod.yaml or deployment.yaml. So Docker container doesn't have YAML as a concept for writing Docker file or everything, but Kubernetes pod is a concept where we write those information in the YAML format. Now, what is a namespace? In Kubernetes, a namespace is a virtual cluster within our physical cluster. It is used to organize and isolate resources. We can imagine that as a large office building that is the cluster, where namespaces are the different departments, that is HR, finance, engineering. Even though they share the same building, the HR team's files are kept separate from the finance team's files. This prevents naming conflicts. We can have a service named web app in the development namespace and another one also named web app in the production namespace without them interfering with each other. Namespace is a virtual cluster inside our physical cluster. Its main purpose is to isolate resources. For example, we can think of office building, that is a large office building, as the cluster that is the physical cluster or the main cluster. And we can think of namespaces as different departments inside that same office building, that is HR, finance, or engineering. So these three can be different clusters, that is virtual clusters inside the main cluster. Even though they share the same building, that is the same main cluster, but HR teams files, that is the virtual clusters files or its data or its working, everything is separate from the other cluster inside that main cluster teams files or its data. So this prevents from naming conflict, and we can have same name services, for example web app in the development namespace or development cluster, and also the same name, that is web app, in the production cluster, that is namespace, without them interfering with each other. Now the role of kubeproxy. Kubeproxy is a network proxy that runs on every node in our cluster. Its primary job is traffic routing. It maintains network rules on nodes. When a request comes in for a specific service, that is like a database, kubeproxy decides which pod should receive that request. It acts as a distributed load balancer, ensuring that traffic reaches the correct container regardless of which node it is living on. Inside a cluster, there is a concept of the network proxy, meaning kubeproxy is that network proxy that runs on every node in that cluster. Its primary job is traffic routing, that would be maintaining networking rules on nodes. For example, when a request comes from a specific service, like it is a database, kubeproxy will decide which pod should receive that request. It acts as a load balancer, ensuring that traffic reaches the right or correct container regardless of which node it is living on. Basically, traffic routing and maintaining load balancer and networking rules on nodes inside the cluster. Now, NodePort versus load balancer. These are different ways to expose our application to external traffic, meaning NodePort exposes the service on a specific port, usually between 30,000 to 32,767 on every node's IP. If we have 5 nodes, we can access the app using any node IP port. It is primarily used for testing or internal services, whereas load balancer is the standard way to expose a service to the internet in a cloud environment, that is AWS or Azure. It creates a single external IP address provided by the cloud provider. It automatically routes traffic to the node ports across all our nodes, providing a professional, stable entry point for users. So in Kubernetes, there is a concept of Kubernetes services, which says that there would be different ways to expose our application to external traffic. There exists cluster IP, NodePort, and load balancer. NodePort exposes the service on specific port with these range on every node's IP. It is primarily used for testing or internal services, meaning we test our application or services in Kubernetes before exposing it to the load balancer. We would be performing NodePort expose to test our application, and then we can expose that application if it is production ready by load balancer. Now, load balancer, this is the standard way to expose the service or the application to the internet in a cloud environment, that is AWS or Azure or other cloud platforms, where NodePort was having the range between 30,000 to 32,767, which is volatile and fluctuating, whereas here in load balancer, it creates a single external IP address provided by the cloud provider. It automatically routes traffic to the node ports across all our nodes, providing a professional, stable entry point for users. Simply, you can understand NodePort and load balancer by knowing that NodePort is a volatile range of port from 30K to 32K approximately. So if we were to expose the application within this range publicly, there would be a lot of conflict and there would be a lot of fluctuations in accessing the application through that service NodePort, because there is a range that is too much or too high, that is like 30,000 to 32,000. So accessing the application would be inefficient. So load balancer acts as a pipe or a filter that creates a single external IP address that is provided by the cloud provider, and it automatically routes that traffic from that single IP address to these node ports that are fluctuating, but it is real-time access. So that single IP address from the cloud provider will route the traffic across these node ports ranging from 30k to 32k. So that single external IP address we can use Route 53 or GoDaddy or other platforms, and we would be assigning that load balancer external IP address inside the web domain or DNS to expose the application. So that is it for the video today. I hope the topic was simple and insightful. Thanks so much for watching. Have a great day. Bye.